Today we're going to look at solving right triangles. Let's recall when we're talking about a triangle, we need to talk about a reference angle if we're going to do trigonometry. Let's say A is our reference angle. We could also call this the working angle. The reason being is we are working with it. The hypotenuse is the side that's across from the 90 degrees. And we have our opposite and adjacent. These two are relative to our working angle. So opposite is the side that is across from the working angle, and adjacent is the side in between the 90 degrees and the working angle. We also have a memory trick where we can remember trig ratios. So, ka, toa. And that represents the first letter of each of the ratios. So we have sine A is equal to opposite over hypotenuse. Cosine of an angle is equal to adjacent over hypotenuse. And tangent of an angle is equal to opposite over adjacent. Now, be very mindful that when you write sine, cosine, tan, it always has to be these functions applied to an angle. Let's recall Pythagorean relation as well. We said that Pythagorean relation is a method to solve the third side when we're given two sides in a right angled triangle. Let's write that down. The reason I'm trying to be very clear about this is because this is something that we cannot apply to a non right angle triangle. The other thing you'll notice is that in Pythagorean relation, other than the 90 degrees, there are no other angles involved. We have two sides and we use those to find the third. Another note is that A and B are the sides that touch the 90-degree angle. So let's solve this. In our case, because C is touching the 90 degrees, even though it is named C, it is really side A. With R5, this is side B, and side C is 9. So when we substitute that into our equation, we have A squared plus 5 squared equals 9 squared. Let's rearrange this equation. A squared is equal to 81 minus 25. A squared, or A, is equal to the square root of 56. This is our exact answer, or we could put it into our calculator and get the rounded decimal answer of 7.5. Another thing that I would like us to remember is the sum of the interior angles. That's the one that says if I have three sides or three angles in any triangle, whether right angle or not, you would have it add up to 180? Three angles of any triangle always add to 180 degrees. Just another quick review about naming convention. When we're talking about a triangle like this, HMN, the capital letters represent the angles, and the little letters that match these are the corresponding angles or corresponding sides. So we have here H as our 90 degrees. So across from H, we have little h representing the hypotenuse. Angle M is 37, and across from angle M, we have the corresponding side, little m, and finally we have angle N and side N. So for us to find the missing angle, since we know that all three angles of any triangle will add up to 180, we can find angle N by doing subtraction. So we have N is equal to 180 minus 90 degrees minus 37. So we have N is equal to 53 degrees. And once again, primary trig ratios, if we're doing it for angle M, our new values are M and H. So we would have sine 37 is equal to opposite over adjacent. Cosine 37 is equal to n over h, and tan 37 is equal to opposite over adjacent. Now, the reason I'm reviewing all that is because in today's lesson, we're going to be putting all of those things together. Sometimes we need to use both trig ratios and Pythagorean relation so that we can solve for a triangle. Now, the word solve means to find all angles and all sides. Let's look at this example. Example, triangle DEF. Angle E is 90 degrees, side EF is 4.9, and side F is 34. Okay, we have our 90-degree angle here. We know that this is labeled E. Let's call this F, and let's call this D. Angle F is 34 degrees, and side EF is 4.9. So E and F, the side in between it, this is 4.9 meters. Now we need to find one angle, and we have two sides left. So first of all, let's do the angle because the angle looks like it's pretty straightforward. We're going to use the sum of the interior angles. So we know that angle D has to be equal to 180 minus 90 degrees minus 34 degrees. So we get D is equal to 56 degrees. Let's use trig ratios now to find one of the sides. I'm going to use 34 as my working angle, but since you've got both non right angles there, you could choose to use 56 instead. But let's use 34. So the sides are going to be named relative to 34. We have the opposite here, and we have our adjacent. So with those two, I'm going to use tangent. So tan F, in this case 34, is equal to opposite over adjacent. Let's cross multiply. 4.9 tan 34 is equal to DE. Let's put this into our calculator. 4.9 tan 34 is equal to 3.3. Our last side, side DF. This is our hypotenuse. We have two choices we could use. We could use trig ratios again to solve for our missing side, or we could use Pythagorean relation because we have two sides already. I'll do Pythagorean relation because I think most students like Pythagorean relation more. So we have 3.3 squared plus 4.9 squared, and this is equal to side df squared. Let's put this all into our calculator. 3.3 squared plus 4.9 squared, and we have 34.9 is equal to df squared. Let's take our square root of that now. And that's equal to df. So df is 5.9 meters. Right, we have solved for this triangle, and we've used three different methods. We've used the sum of the interior angles, trig ratios, and Pythagorean relation. Another example, triangle GHI. H is 90 degrees, side HI is 9.2, and side GI is 11.3. Okay, we know that this is side H, or sorry, angle H. Side H is on this side. Let's label a G and an I as well for the angles. Now, GI, which is the hypotenuse, is 11.3 centimeters. HI is 9.2. HI, we need to find angle G, angle I, and side HG. Let's start by finding the angles, and we're going to do that using trig ratios. Let's say that G is my working angle. If we have G as our working angle, this is now our opposite, and this is our hypotenuse. That means we have to use sine for this one. So sine g is equal to 9.2 over 11.3. Let's undo our g by using sine inverse. Let's put this in our calculator. Sine inverse of 9.2 over 11.3. G is equal to 54.5. I'm going to round it to 55 because I have a 5 as my first decimal, and as the nearest degree, it's going to be 55. Next one. For angle I, I'm going to use sum of interior angles. I know that all of it has to add up to 180. So I is equal to 180 minus 90 degrees minus 55. All of that is equal to 35 degrees. So we've got two values now. And our third one, we can use Pythagorean relation, or we could use trig ratios to solve for our last side. I'll use trig ratios to be different from the last one. Let's use G as our reference angle again. But this time for G, the side that we're missing is the adjacent. Okay, let's do cosine G is equal to adjacent over hypotenuse. Let's fill in the values. So cosine of 55 is equal to adjacent over hypotenuse. Let's simplify it. Or sorry, let's not simplify it yet. We have to cross multiply first so that we have the most exact answer. 11.3 times cosine 55 is equal to hg. Let's simplify some, uh, let's type it into our calculator now. 11.3 times cosine 55. This is equal to 6.48. Let's round that to one decimal spot, and we have 6.8. Sorry, 6.5. Slides number 8, 9, 10, 11, 12, and 13. I'd like you to pause the video and try some of these on your own. Here's the solution for slide number 8. Solutions for slide 9. Solution for slide 10. This is a solution for slide 11. Solution to slide 12. Slide 13 solutions. Next part of the lesson. Sometimes we're given two triangles and we need to solve one to help us solve the second. In this case, we're asked to find the side EF to the nearest meter. You'll notice that we do have an issue when we're looking for EF. EF is part of this second triangle. It only has two angles, and two angles is not enough for us to use trig ratios or Pythagorean relation to solve for a side. We need to have at least one side. Now, if we look at the first triangle, though, we do have two pieces of information. We have one angle, one side. I'm going to use that to help us find EG. And then after I find EG, I'm going to be able to use that to find EF. So here's our strategy. Find side EG. Then we're going to use EG to help us find EF. So let's do our first one. Angle is here. This is our hypotenuse and the opposite. So I know I'm using sine. We have sine 43 is equal to 150.5 divided by EG. Let's cross multiply. So now we have EG times sine 43 is equal to 150.5. All right, let's wind our way up here. Let's rearrange again. So EG is equal to 150.5 divided by sine 45. Our calculator tells us we have a length of 212.8. Now for our last side, now that we've found side EG, we can find side EF now. We're going to use the side that we calculated here, 212.8, along with our 35 degrees to get this hypotenuse. We're going to use cosine this time because relative to the 35, this is our adjacent. Cosine 35 is equal to adjacent over hypotenuse. Let's cross multiply is equal to that. And we're going to rearrange again. And put it all into our calculator. Finally, we have EF is equal to 259.8, and that's our rounded answer. Now we have another question similar to that. We need to use what else we're given in order to find what we're looking for. So find side AC. AC, oops, is this side here. We have two angles again, but this isn't helpful. Now, one thing I do know though is that CD is the common side. So if I can find CD, then I'm able to find AC. Right, so let's write down our strategy. Find CD, then we're going to find AC. CD is a shared side, and so once we find that, we're going to be able to find our AC. So let's start. Side CD. This is our opposite and this is our adjacent. So we have tan 72 equals opposite over adjacent. CD is equal to tan 72, or let's write this better, 6.1 times tan 72. Now, it's math convention that you usually write your number that doesn't have a trig function in front of the one that does. 6.1 times tan 72, we have CD is equal to 18.8 meters. Right, now that we have this, we're going to look for side AC now. AC, we have the opposite and we need the hypotenuse. So we're going to use sine. Let's cross multiply. And the rest is calculator work. 18.8 divided by sine 37. AC is equal to 31.2 meters. One more example. We need to find side GF to the nearest meter. GF is this side here, and the unique thing is we don't have any information for this side. We need to find an angle and a side in order for us to find FG. Now, it's possible for us to find side HF by subtracting. So let's start that as our strategy. Find side HF. Then, if we found the angle IHE right here, then we're able to find this angle. After that, we're going to find angle GHF, and finally, we're going to find side GF. Great, let's get started. So HF, we know it's 40 degrees minus 15. So HF is equal to 25 centimeters. Now the second part, for us to find this angle, we need to use these two sides and a trig ratio. So if this is our angle that we're looking for, we have the adjacent and the hypotenuse. So we're going to use cosine. Cos IHE is equal to adjacent over hypotenuse. Let's undo the cosine now. And we have IHE is equal to 44 degrees. So we've done the first two steps. Step 3 now. Angle GHF. We know that a straight line is 180 degrees. So if I take 180 and subtract these two angles, then we have this remaining angle. 180 minus 115 minus 44. Okay, we have angle GHF is equal to 21 degrees. Finally, step 4, we're going to find side GF. Now that we have one side and one angle, we can find our second side. This is our adjacent. This is our opposite. Let's use tan. Tan 21 is equal to opposite GF over adjacent. Let's cross multiply. 25 tan 21 is equal to GF. And GF is equal to 9.6 centimeters. All right, pause the video. Try slide number 17 and slide 18. You can get the solutions in class for this one. Oh, slide 19 as well. And now I'm going to do a word problem. You're flying a kite with a 100-meter long string. Draw a diagram when the string makes a 36-degree with the ground. Find the height of the kite. Round it to the nearest meter. Now let's draw this. We have U standing here, and you are holding a kite. We also know that if we dropped a perpendicular, we could create a triangle with it. Here's our kite. I know that the string of our kite is 100 meters long. And the string is making a 36-degree angle with the ground. Now I know that this is the ground, and this is just a perpendicular that we dropped. The perpendicular also happens to be the height. Because if we can find this value, then we know what the height is. Now, I'm interested in this, our opposite, and I'm given the hypotenuse. So I'm going to use sine. Sine 36 is equal to the height over 100. 100 times sine 36 is equal to our height, and we have 100 times sine 36. H is equal to 59 degrees. Or sorry, no, it's a height. So 58.8 meters. They want us to round it to the nearest meter. So we're going to round it to 59 meters. Another example here, draw the diagram and solve. The Eiffel Tower in Paris is 300 meters high and it casts a shadow of 160 meters. Find the angle that the sun's rays make with the ground. Round it to the nearest degree. Let's draw this. I'm going to attempt an Eiffel Tower, but I'm going to say I am no artist. Maybe we could say that's our Eiffel Tower. Now let's represent the Eiffel Tower by a straight line. I'm going to label this, and then I'm going to label a couple of other things. We know that it forms a shadow, and this is our shadow. The shadow is 160 meters. Now the third side that we're going to create, this is from the sun. So the sun's rays is shining down and it creates a shadow. So this one is our ray. Find the angle that the sun's ray makes with the ground. Now the shadow is on the ground, and here's the sun's ray. These are two sides, and the one that's in between is the angle that we're interested in. Let's call this angle D. We have angle D, we have 300 and 160. This is going to be a question that involves tangent. Tan D is equal to opposite over hypotenuse. Let's undo our tan. And we have 62 degrees. That's rounded from 61.9. Okay, slides number 22 and 23. These are questions for you to try on your own. Once again, if you'd like the solutions, we'll take it up in class. Thanks for watching today.